In this tutorial, I'm going to show you how to conduct a randomization test to test a claim for a single proportion in R using the functionality in the Mosaic package as well as ggplot2 in order to create a plot of the randomization distribution. The first step to carry out is to load the two necessary packages, and that would be the Mosaic package and the ggplot package. Remember that you may have to install these packages if they are not yet installed on your machine. And the situation that we have here is that at one point in time there was an octopus named Paul who predicted 8 out of 8 World Cup matches correctly. And the question was, well, is that possible by chance alone, or could there be something else going on here? Of course, this is kind of a silly little example, but it provides a good example of thinking about generating fake data for a single proportion in order to carry out a randomization test. And so what we need to do here is that we need to devise some model that could represent Paul just guessing at the matches, because under the null hypothesis we will assume that Paul is simply guessing the outcome of the matches, and that could be the flip of a fair coin. Under the alternative hypothesis, we would think that he's doing better than guessing, so that he will guess a higher proportion. So that would be greater than 0.5 in terms of our alternative hypothesis. Now that we have our hypotheses understood, we need to figure out a way to simulate that in R. Well, in the Mosaic package, there is a function called rflip. If you want to pull up a help file, type question rflip, and that's going to basically flip a coin one time by default. It's going to be a fair coin by default. If you look down here in the help file, you can add an argument making it a biased coin, such as if you wanted it to land heads 80% of the time, you would put prob equals 0.8. But for us, a fair coin is sufficient. So Paul was guessing under the null hypothesis on 8 World Cup matches, and so we'd want to generate 8 flips of a coin. And that's what rflip 8 does. So if we run that down in our console, we'll see a string of 8 heads or tails. So in this just guessing situation, it was heads, tails, 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 heads, tails, heads, tails, which gives us 3 heads for a proportion of 0.375. Just like with any randomization distribution, we need to do this a couple times, many times in fact, in order to understand the behavior of this proportion under the null hypothesis. So notice you can generate a couple more and you'll get different strings of heads and tails. So let's do this 1,000 times. Remember, we're going to use the do command with the number of trials that we want in parentheses, star the function that we want to replicate a number of times. So we want to flip a coin 8 times, 1,000 times. And we'll store that as the Paul null object. So we run that, and then we get a Paul null object. Let's open that in our viewer, and what you'll see is that for each trial here, we have 1,000 rows. So that's all 1,000 trials. It's recorded the sample size, so how many times did we flip our coin? That's 8 in each case. It records the number of heads and tails, as well as the proportion of heads, which is prop. Now that's going to be important because that's exactly what we want to look at. Let's visualize this randomization distribution, so let's look at what all 1,000 proportions look like. We're going to use ggplot to do that and just make a simple histogram. So we run this and we'll see our histogram jump up here in the bottom. Notice that there are only 8 flips, so there are only so many possible proportions here, which is why there's a lot of space between these bars, but it gives you an idea about what could happen under the truth. Notice that we are centered here with this histogram at 0.5, which is what we are assuming is true when we're flipping a fair coin. In order to superimpose the data that we observed, which is 8 out of 8, or a proportion of 1, we can use geom_vline. Running that code, you'll see that we've put the geom_vline here up at 1. There are some number of times that 1 occurred in the data set, so we need to understand what that number actually looks like out of 1,000. So we can use the prop function in the Mosaic package to quickly calculate the proportion of the proportions. So remember, in the Paul null data set, there was a prop column. That's what we want to look at. We want to look at how many of those proportions are greater than or equal to 1, which is why we specified to the right of the tilde prop greater than or equal to 1. And so running this, we'll see that in this simulation, 4 out of 1,000 trials resulted in a proportion of 1 or greater. We're maxed out at 1, so of 1. And so this would be the p-value in a test. And what this would tell us is that in 0.4% of simulations, so 4 out of 1,000, just by guessing, you would expect to see 8 out of 8 occur. And that is relatively strong evidence against the null hypothesis. Of course, this doesn't mean that Paul somehow had the ability to predict matches, but it does say that this was very, very unlikely. And so now you need to think carefully about how to make decisions based on p-values from tests. This is how you can create a randomization distribution in R using the functionality in the Mosaic package, as well as plots using ggplot2.